Okay, so in this video, we're going to talk about solving multi-step inequalities, or inequalities that have more than one thing to get rid of in order to isolate your variable. Like in this example, you have that 3n, so you got to get rid of that 3, and then the plus 6. So it's going to take at least 2 steps to get the variable n by itself. Now you do this in the same way you would have done the one-step inequalities, except you have to do extra steps. So in other words, do everything you would do to solve a regular equation, except you have an inequality symbol instead of an equal sign. That means instead of having a finite list of answers, you have an infinite set of answers that are possible, and you can use a graph to represent those answers. Now, remember that the principles that you follow for equations can be used to solve inequalities. It's the same thing. So in other words, you're going to go in reverse order of operations to isolate your variable. So you work on the side that has your variable, and you're going to do that by doing the same thing to both sides. And the thing that you do is the opposite of the thing you're trying to get rid of. And you keep doing that one step at a time until the variable is by itself. Let's see how that works on this video. Don't forget that there's a difference when you're doing inequalities in the sense that if you divide or multiply by a negative, then you have to flip the inequality sign. So if it used to look like this, then it will look like that, right? So the idea is that the inequality sign changes orientations when you actually have a division or multiplication by a negative number. But we'll see that on the next video. On this first video, we're not going to see any examples like that. We're just going to practice the steps of solving equations to solve inequalities. All right. So over here, the Triceratops is guarding this problem. We got to get it first. Oh, but don't forget, by the way, that you can pause before I solve the problems. And that way you can try to practice it yourself and see if you got the same answer that I do. First thing you need to do is get rid of the plus 6, because I have to go in reverse order of operations and isolate the variable that's on the left side here. So to get rid of a plus 6, I have to subtract 6 from both sides. So if I subtract 6 from both sides, I will cancel out the plus 6 from the left. And on the right side, 6 and 6 together make 12. I'm putting them together because they're both negative, and I keep the sign. So two negatives make it even more negative when you're adding, and so you get negative 12. And you have left the 3n on the left side. Now, because I didn't divide or multiply by a negative, I keep the orientation of my inequality sign. Now, it's important to realize, yes, I did subtract by a negative. Yes, there was a negative originally in the problem, but that's not the criteria. The criteria is not just, oh, there's a negative, I'm going to flip the sign. You have to divide or multiply by a negative in a step in order for the inequality sign to flip. All right, the next step here, we have to get rid of this 3, right? So now how do I get rid of a 3 that's multiplying my variable? I have to divide, and I always do that. I always ask myself, what is that number doing to my variable? So since in this case it's multiplying, I'm going to divide both sides by 3. When I do that, I have n by itself smaller than negative 4. So if Mr. Triceratops will get out of the way, excuse me, Mr. Triceratops, you're extinct anyways, goodbye. We can see the graphical answer for that. We do not include negative 4 because negative 4 is not an equal sign there. It's just smaller than. And then I go left because I want numbers smaller than negative 4. So as you can see from this problem, I actually did it in 2 steps, exactly like I would to solve an equation, except at the end, I had an inequality sign instead of an equal sign, and I had a graphical representation for my answers since I have an infinite number of possibilities. Let's try to do a tougher problem, this time involving fractions. But don't be scared. Just because there's fractions, it's going to be okay. Besides, this dinosaur looks like Barney. How serious can he be? I'm not even sure what he is. Is it a, maybe it's a Tyrannosaurus Rex, but 2 big arms, right? So I'm guessing it's an Allosaurus. Perhaps, who knows? Whatever. Now, notice I'm going to work on the right side here. Why am I working on the right side? Because there's nothing to get rid of on the left side. My variable's on the right, I got to work on the right. And I have to go in reverse order of operations, so I got to start with the thing that's being added or subtracted to my variables. And that's going to be my 2/3. So I'm going to do the 2/3 first. Remember to pause before I try it so you can do it on your own. To get rid of the 2/3 that is added, I have to subtract 2/3 from both sides. When I do that, I'm going to cancel out the 2/3 from the right over here, and then I'm going to have 2 minus 2/3, which is 4/3 on the left side. And I'm going to go a little bit to the left here because this Barney-looking thing, I mean, it's almost a Barney. It's got a purple spot on the back, but it's not quite as happy as Barney is. All right, anyways, the sign stays the same orientation because I didn't divide or multiply by a negative. I just subtracted a negative, so that does not change my sign. And on the right side, I still have 3/5 times g. Now, remember, to get rid of a fraction, the best thing you can do is to multiply by its inverse. And the reason you're going to do that is that this fraction is really what? It's multiplying my variable, right? So if you realize that it's multiplying, you have to divide by it. So by dividing by a fraction is the same thing as multiplying by its inverse. Remember, copy, dot, flip? So you can just multiply both sides by 5/3. I'm going to write right over the face of this dinosaur. So if you multiply by 5/3 on both sides, you're going to be able to cancel out the fraction on the left. Another way of thinking about this is that you are first dividing by 3 and then multiplying by 5 on both sides. And that's the same thing as multiplying by 5/3. Now, when you do that, the fractions cancel out because 3 times 5 is 15 and 5 times 3 is 15. So that's 15 over 15, which is 1. So you just got rid of the fraction. And all you have left on the right side is g. Now, that's going to be bigger than, because g is facing the bigger side, then whatever you get on the left side. 5 times 4 is 20. Remember, multiplying fractions, you use top times top and bottom times bottom. 3 times 3 is 9. So this will be 20 over 9. And that is our answer. Now, you could rewrite this if you want to put the variable on the left side, which helps you realize what you need to do to graph. But remember, if you flip the orientation of the sides, you also have to flip the sign of the inequality so that his statement is still true. Because after all, we are looking for numbers which are smaller than g. So g has to be bigger than the 20 ninths. By the way, 20 ninths is the same thing as 2 and 2 ninths. And that might help you create a number line graph that makes sense. Excuse me, weird dinosaur that I think is an Allosaurus. Let's see what the answer is. And indeed, you are not going to include 2 and 2 ninths because it's not bigger than an equal sign. So you put an open circle and you're going to go to the right because I want numbers bigger than that. So in this video, I showed you that even when there needs to do special tricks like the one we did with the fractions, it's basically the same as we used to do with equations, except we, in the final end, have a graphical answer with a set of answers. But other than that, it's essentially the same principles as doing equations. Try to work on the side that has a variable. Isolate the variable by going in reverse order of operations to get rid of numbers by doing the opposite of what they're doing to the variable to both sides of the equation, one step at a time until the variable is by itself. And that's all there is to it. On the next video, I'm going to show you an example when there is a negative division or multiplication that you do in inequalities and what it does to the sign and your answers. I'll see you guys then.